It is 1.3 million people living on 7 islands, thousands of miles from the nearest mainland. The Hawaiian Islands depend on a steady flow of raw and processed petroleum resources. 75% of Hawaii's petroleum flows through one single-point mooring marine terminal located here off the southwest tip of the island of Oahu. This is the Kapolei Refinery, operated by Tesoro Hawaii Corporation. These critical marine pipelines begin here at the onshore terminal facility, where they lie buried for a distance of nearly a mile. There are 3 pipes in 3 diameters, a 16-inch pipe for bunker oil, a 20-inch for refined products, and a 30-inch pipe for crude oil. They run submerged beneath the surf zone for another 4,500 feet. The remaining 5,500 feet are founded directly on the sea floor, terminating at the offshore subsea pipeline end manifold, or PLEM. PLEMs are connected to the SPM, or single-point mooring, calm buoy marine terminal by submarine hoses 1.7 miles offshore. Their total run, a distance of 2.8 miles. Completed in 1972 by Tesoro's predecessors, the Kapolei Refinery marine offshore pipelines are regarded from that date forward as impossible to inspect or monitor through the process of inline inspection, or ILI. There is no facility to launch or retrieve the principal ILI tools, called pigs, and once inside the 30-inch crude oil pipe, the ILI pigs would encounter an internal obstruction to their free passage. Since 1972, regular inspection is confined to hydrostatic testing, ultrasonics, or UT, and visual surveys offshore. For more than 3 decades, full inspection of the pipeline's interiors has remained just out of reach. As the pipeline's responsible caretaker, Tesoro Hawaii begins a feasibility study in partnership with Alaska's Kaufman engineers. The goal? To set a baseline for the condition of the pipeline, and with this, determine a regular inspection schedule. The method selected is bidirectional magnetic flux leakage inspection technology, or MFL, chosen for its less stringent cleaning requirements. Few vendors can supply the needed BiDi technology, and there are tight and busy schedules for ship cargo delivery. The project must be broken into 2 phases. Phase 1, 2007, fabrication of pig launcher receivers and pump manifold, modifications to the marine manifold, and additional piping to a freshwater supply tank, Tank 902. Phase 2, 2008, the implementation and execution of the actual ILI. And in January 2008, Tesoro and Kaufman engineers will link with 3P Services out of Germany. It is by then a global team with far-ranging experience and broad histories of innovation and expertise. Fall 2007. Phase 1 begins inside the fence with the modification of the Kapolei marine manifold. The pigs will begin and end their inspection runs here. Launcher receivers are fabricated for later installation, and a pump manifold is built to manage the water flow rates required to push the pigs. At Tank 902, located near the marine manifold, piping is added to supply fresh water for the pigging process. At the offshore end of their travels, the ILI pigs will stop here, just short of the expansion loop and PLEM, at which point the water flow from Tank 902 is reversed through the pipes, and the pigs start their run back to the onshore launchers and receivers. Another contractor, Sea Engineering, executes a detailed offshore survey of the pipeline to ensure precise coordination between known datum points and the moving inline tools. ROVs and multi-beam surveys precisely locate the pipeline's anchor blocks and the offshore PLEM. Marker boxes and positioning antennas are introduced along the subsea pipelines, acting as stop alerts for the pigs and contributing to future references, while pre-project surveying and excavation begins for marker boxes and tracking devices onshore. And finally, the ILI pigs themselves are readied. A minimum of 5 pigs will be used, each one uniquely tasked, all state-of-the-art. The process of progressive pigging begins as the pipeline is cleared of products with a seawater flushing. Now, fresh water from tank 902 will propel each pig through the line. The first 4 pigs are dumb pigs, devoted to cleaning and prep for the actual Smart Pig MFL tool run. Pig 1 is a bidirectional foam pig. Any intrusion or irregularity in the pipe walls will cause deformation or damage in the foam covering, which is noted before subsequent pigs enter the pipe. Pig 2 is the disc pig, with gauge plate and polyurethane discs. It will determine if the maximum diameter of the MFL tool will be able to pass. It also acts as the first cleaning pig. Pig 3 is the scrubber pig, a more aggressive cleaning process using steel brushes. Pig 4 is a magnetic disc pig designed to pick up metal particles. It is the final cleaning pig. Once all pigs return and are okayed by the MFL tool technicians, the pipeline is ready for the actual MFL tool run. Pig 5, a bidirectional MFL or magnetic flux leakage inspection tool, is the Smart Pig, a mapping and scanner pig. It will show any anomalies it may encounter in fine detail and with precise location. At the close of 2008, Phase 2 is complete. Multiple runs of ILI dumb pigs have scoured the lengths of the 3 product pipelines, and MFL Smart Pigs have traced every flange and fitting, every elbow and every weld, and mapped every incidence of damage or corrosion. The data is accurate, the testing and mapping successful, and the report shows a pipeline in very good health. In 2009, discovery, confirmations, and minor repairs as required will continue. Corrosion trends will be analyzed and evaluated, and the experience will soon translate to inspection of the marine offshore pipelines on a scheduled basis. Through the worldwide partnership and team approach of Germany's 3P Services, Alaska's Kaufman Engineers, Tesoro Hawaii Corporation, and other talented contractors, a baseline status of the unpiggable pipeline is now in hand.